Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to talk and dissect all of the outputs that we get after a regression. The first time you see a regression output, it will definitely feel overwhelming, especially if you've never done statistics or econometrics before. You're going to see rows, columns, numbers everywhere. But there's a good news. Regression output is not random. And hopefully all of the information on the videos that you have seen so far in this playlist will give you a hint to what you should be expecting out of the numbers of a regression output. The regression output is a very structured summary of a few key ideas that you have already been introduced to. So in this video, we'll learn how to read regardless of the software that it's used, just conceptually. What the regression output answers will fall into one of these four categories. What relationships did we estimate? How uncertain are those estimates? What can we infer statistically? And how much of the data variation did the model explain? So expect that every number that you will see in your regression output, regardless of this is in Stata, R, Python, and so on, it will belong, every number will belong into one of these four categories mostly. Let's think about the first one. So estimated relationships. The heart of a regression output is the coefficients in the table, which we have talked about quite extensively, especially in the video on jargon and the population model in econometrics. We've talked about rows and columns in an Excel spreadsheet, but when you have the output regression, the rows now take a different meaning. In a table that gives you the output, every row corresponds to one explanatory variable. So for, let's call this block A, you're going to have a row being one explanatory variable. Then you'll have one more row which has the information on the intercept. And as you know, the coefficients tell you the estimated relationship between x and y, holding other variables constant. Keep in mind, whenever you're doing these estimations, we're only looking at like what numbers you should be expecting to see, and we're not going to make an inference yet. The second block, so let's call this block B. How uncertain are these estimates? So a coefficient alone, which is what we get out of the first block, is meaningless, especially without with all the uncertainty involved. So that's why regression output always includes measures of variability. And in this case, what I am talking about is standard errors, confidence intervals, t-statistics, all elements that you have now been introduced to in this playlist. These numbers answer the same question from different angles. How noisy is this estimate? The third block, let's call this block C, is what can we infer statistically? So once we get these numbers and also these measures of variability, we can start thinking about making inferences. And using estimates and uncertainty, so based on the t-statistics, p-values, or stars, you can make decisions and statements about how surprising the estimate would be if a null hypothesis were true. Keep in mind, they are shortcuts, not substitutes for thinking and then making conclusions for whatever sort of relationship you're trying to estimate here. So I'm just going to write here hypothesis testing. so that you remember, based on the elements that you are given, you can start getting some answers from your hypothesis testing. The last block, let's call this block D. How much of the data variation did the model explain? Outside the coefficient table, you'll usually see information like the number of observations, or R square and adjusted R square. You'll see something called F statistic, and a lot of other elements which we'll see even more precisely once we see outputs from actual software. But these tell you how much data you used, how much variation the model explains, and whether the model has some sort of joint explanatory power or not. So they describe the model as a whole. So not just the individual coefficients. So as you can see, the numbers, they give you a variety of types of information. And as long as you know that it will fall into one of those 4 categories, then you can concentrate on the numbers that you are interested in for answering a particular question. Now, there are also certain things that a regression output will not tell you. And this is just as important to know as much as like what it actually tells you. So the things that you are not told through a regression output is whether the model is correctly specified, whether assumptions hold, or whether relations are causal. Or causal, sorry. Those require judgment, diagnostic, and theory. And that's why most of you will see in your lectures, you have special bits just on diagnostic tests. Okay. So keep in mind, output summarizes result, but it does not validate them. A helpful way to read regression output is to ask, what was estimated? How uncertain is it? What can I infer? And how good the model is overall. If you can answer those 4 questions, that means that you understand the output regardless of the software that you are using. So once again, as a key takeaway, take that regression output is a structured summary of estimation, uncertainty, inference, and fit, not a wall of unrelated numbers. Thanks for following this video, and I'll see you in the next one.